The goal or purpose of this activity is to try to figure out whether these three substances can exist in this in-between phase of it not being entirely a solid, liquid, or gas. It's asking you to provide evidence of how you know or what you're seeing, really kind of like an observation of what the molecules are doing, and then trying to answer, how did you find this evidence in the simulation in the first place? So what did you have to do in order for it to be in this in-between stage? Okay, so in order for us to successfully complete this, we'll need the simulation, and you'll probably need your notes as well, so that you can see the difference between what a solid, liquid, and gas kind of looks like, how the molecules behave or move in that case, just so that we can have really clear sight lines of what we're looking for this particular activity. So we're going to start off with substance A. We are going to keep the gravity on. It just makes it a lot easier for us to really determine what the substances are like on Earth. So we're going to click the play button. Okay. And so just by clicking play, it automatically sets us as at 36 degrees. And this is what the movement of the molecules look like. Now, just in general, because of the movement of these molecules, we can tell that they are in a solid phase. Why? Because the movement of the molecules are staying in place. They're moving kind of as a whole, and there's really not much freedom of movement at all. Okay, so since we're starting off as a liquid, I'm going to add or transfer energy in by clicking the plus sign until I start seeing some sort of a transition where I'm thinking that it may be a liquid. Okay, so once I start seeing more freedom of movement among these molecules, I can tell that a phase is about to happen or already has happened. So I'm going to continue to add or transfer energy in. Right now I'm at 98 degrees. There we go. Okay, still moving, a little bit more movement than before. However, they're still kind of moving as a solid. They're moving around each other rather than around, they're moving in place rather than moving around each other. So I'm going to continue adding in more energy. Okay, and then this is what we're looking for. We're starting to see that some of these molecules are separating and getting to move around a little bit more. Okay, I'm going to continue to add in a little bit more. Okay, so now that I'm seeing multiple molecules separating from the regular cluster of what a solid typically is, I can assume that this substance is in that in-between solid and liquid phase. So as in terms of evidence, the molecules' freedom of movement is higher. And what did I do? I transferred energy into it until I reached this phase or stage. So just to recap, at this stage, we are seeing that even though the majority of the molecules are staying still, we are seeing more freedom of movement, and we are seeing molecules moving around in the container. Okay, so that itself is proof that this isn't 100% solid, that it may be liquefying. So think about maybe an ice cube. And if you have it sitting out for too long, the majority of it's still going to stay solid for the first few minutes, but you are going to start seeing a little bit of liquid forming from that. Okay, now we are selecting substance B. Okay, substance B is moving like a liquid, where the majority of these molecules are staying towards the bottom and they are moving around each other rather than by themselves or moving back and forth within that same spot. However, this is something very interesting because right from the get-go, right from resetting it, selecting substance B at 36 degrees, we are seeing that this is in a transitional phase where it's not 100% liquid, because we are seeing tons of little molecules that are trying to move freely around the container. And that is evidence of a transition or moving from a liquid to a gas. So let me see if we can do this, if there's a transitional or in-between spot for a liquid to a solid. So at this point, yes, it can be in a space or a moment where it's in between liquid and gas. And then now we're going to try to figure out if we can transfer energy out enough so that it's mainly liquid but also turning into a solid. Okay, so I think at this point I didn't even have to take out too much energy. I transferred energy out just a little bit. Okay, we're down to a negative 57 degrees, and we're seeing that there are still a few of these molecules still have freedom of movement where they're trying to take up the container or take up space within the container, whereas the majority of them are still kind of moving around either each other or staying in their same spot. So let me see if I were to take out even more energy, all of the different, there we go. Okay, so we still are kind of in a state of liquid and solid, a lot less movement with these molecules. Okay, I'm seeing that they're kind of staying in their spot. I'm not really seeing them moving all too much. Okay, so for your charts, as soon as we selected the substance, which is substance B, we saw that it was already in kind of this in-between state or phase of being a liquid and a solid. Liquid and gas. Sorry about that. And if you were to remove energy from it being a liquid, you could see that it's also somewhat in between that liquid and solid stage. Okay, we're going to reset, select substance C, and this is going to be the last substance. We're seeing that this is very much a gas at 36 degrees Celsius. So I can, since we're already at the highest freedom of movement as a gas, I'm going to try to condense it. And the way that I'm going to condense it is by taking energy out. Okay, we're starting to see a little bit of change in movement. Okay, I'm at negative 158 degrees now. Okay, now at this point, the majority of these molecules are acting like a liquid, where they're staying towards the bottom, they're moving around each other rather than staying in place and kind of shifting back and forth or moving in its place. And we're still also seeing a lot of the different molecules that are trying to kind of jump up and take up space in the rest of the container. So right now we are in that in-between spot between a liquid and a gas. So we have condensed down to mainly a liquid. Now let's see if we can rotate this to see if they will act like a liquid, right? If you were to tilt a container of water, it would also move along with that. So we see evidence that this is acting or does have traits of a liquid, because when we tilted it, the majority or all of the molecules started moving towards the bottom of the container again. Okay, so now for substance C, we're gonna try to figure out if we can form a solid from the kind of in between liquid gas stage that we were just at, and see if it can be in a stage or a place where it's in between that solid and liquid phase. And I think by the looks of this, we have kind of reached that, where the majority of the molecules towards the bottom are moving in place. And then as we shift up a little bit, we are seeing a little bit more movement. We're seeing its attempt to kind of take up a little bit more in the container. But all of the molecules in like the bottom 3-4 rows are essentially kind of locked into place, where they're not moving very much. They're just moving in place. Okay, so recap, all substances were able to kind of be in that in-between mode, whether that's from gas to liquid, liquid to gas, liquid to solid, solid to liquid, with just the right amount of energy being transferred in and out. Again, this kind of solidifies the idea that you can transfer enough energy in or out, so that there's not a complete phase change that occurs, but enough so that you're seeing, at a macro level, you're seeing some changes, right? In the case of a solid being in between a solid and a liquid, you would see it as an ice cube melting. And from a liquid to gas, you can kind of start seeing the steam a little bit, or you're starting to see some sort of condensation on your cup, or those few droplets on the soda can or on your really cold drink. This is a super long video. However, I'm still seeing a lot of students that can't access Amplify at this very moment. So I think these will continue until we're able to kind of sort that out. Again, I apologize.